Rye, Jonathan, where do you want to start?
I just have one specific question from chapter 12
Okay.
and some more general things for 12 and 15.
All right.
Sorry, for 13 and 15. So the question I had in chapter 12 has to do with the reward to risk ratios.
Uh-huh.
So I understand how you get that, like for the individual securities and stuff, that it's like the slope is like the MRP over the beta.
Right.
But I don't understand how you get to the point where those are equal for all securities.
Okay. Let me pull that up in the book. Or maybe even the slide deck. The slides might be helpful on that, wouldn't they? Let me go to that. And I need to get out of the way. I don't have my handy dandy Stream Deck running, so kind of got to do it the old-fashioned way. So you're talking about kind of right, starting at more or less at this point, right?
Yeah, right about there.
Okay, so basically the way it works out is that, so we've got this one asset A, and we see that it's got a 7.5% risk premium for a unit of risk. And then we've got this other asset, asset B, that only has 6 2/3. Nobody wants asset B. Here's kind of maybe one of the assumptions that you might be wondering about that I didn't spend a lot of time talking about it in class. If nobody owns something, it doesn't exist. So we're kind of waving our hands a little bit here and saying, well, let's pretend that it does exist and it's just mispriced. All right. And so if this is mispriced, everybody's trying to sell this guy and go into A, right? Because A has, per unit of risk, A has a better payoff. And remember, that's scaled. We're always predicating this upon where the risk is the same, but I'm getting 7.5% on A, and I'm only getting 6 2/3% on B. So I always want A. So I'm selling B, and I'm buying A. All right. So now the other weird part in here, and I did talk about this in class, but this is kind of the tougher one to really see and understand. So it bears repeating. We think about, if we think about the world as simply a one period model, we start here and the world ends here. And so we buy an asset at time 0 and we get a payoff at time 1. And this thing has been, that's how they started off with this model way back 50, 60 years ago. But now it's been generalized to a multi-period model, which just makes it more complex, the math behind it. So, but the one period model gives us the intuition. So the way this is always structured is, let's say that we have a security that pays $1 at time 1. Now, the price at time 0 is right now up in the air. And it's a function of supply and demand for that asset. So if you think about the return is ending minus beginning over beginning, right? So that gives us our percent return. So the ending is always the dollar. So we're looking at $1 here, and then what do we buy it for over here? So now the question is what do we buy it at? Let me figure out what would give us a 7.5% return. So I'll get an exact number for us here. So if we priced A at 93.02, and I'm going to round 02, well, yeah, round off at 5 places. All right. So that price, if we plug it into this, that's going to give us a 7.5% return. Okay, so that's asset A. Asset B is going to be priced at $93 and $750. Okay, and when I plug that in, actually let me finish this out with the, okay, so this one would be 1 minus 0.93023 all over 0.93023. That'll give me that 7.5%. So that's for A. For B, I get my 6 2/3% by 1 minus 0.93750 all over 0.93750. Okay? All right. Now, so everybody's running from B, running toward A. What's that do to the prices? Think about our simple supply and demand model. If we have excess demand for A, that drives the price of A up, right? So we started off here. So let's see, it goes to 0.931. Okay, when I plug that in, 1 minus 0.0931 divide by 0.0931, I get the wrong answer because I didn't do that right. 1 minus 0.093. What am I doing? I'm doing O. That's why. 1 minus 0.931 divide by 0.931. And I get, when I do that, that gives me a 7.4% return. All right. But you can see the pattern, obviously, as I keep demanding, the price keeps going up, which keeps causing the return to drop. Because remember, we're assuming that the payoff at the end is $1 always.
Yeah.
Now,
So does this basically go to the point where asset A's price climbs and asset B's price goes down to the point where the return is equal?
Yep.
Okay.
Yep.
That makes sense.
Yeah. But
It doesn't start that way. It just kind of progresses towards that direction.
It does, right, as arbitrage takes place. And so that selling pressure on B is going to drive down the price of B. Selling pressure on A is driving up the price, which, now that's when we talk about price, but when we talk about return, that drives down the return of A and drives up the return of B, and eventually they meet in the middle or somewhere thereabouts. Certainly there are other parameters that might move one faster than the other. Depends on how much liquidity there is in each one. If we assume it's equal liquidity, then they actually probably do meet directly in the middle. And we have, so that would be what, a third plus a half plus 3/6, 2/6 plus 3/6, so 5/6 of the way. Or no, 2.5/6, right?
Okay. Yeah.
So somewhere a little over 7%.
Okay.
But this understanding or kind of using this little tool right up here, what we call these securities that have $1 payoff at the end and are some sort of discounted pricing at the beginning, we call these Arrow de Brue. Securities.
Okay. So that's when they come together in their return?
No, this name is just the type of, it's just this idea that we have a security that has a known dollar payoff at the end.
Okay.
And it's sold at some sort of discount prior to that. But I think that does that get at the heart of your question, or am I still maybe
Yeah.
missing some of it?
Yeah, no, I understood the slope and everything. So is it just that like if the MRP of A is higher than B, is the beta of B going to be higher than A? Is that just how that evens out?
Oh, yeah. Now we can have, yeah. So we can still have A and B having the same slope.
Mm-hmm.
That's still the same slope, but the riskiness of A and B can be different.
Yeah.
So if say A has a beta equal to 1, the MRP on that might be, say, let's call it 7%. Well, and so this would be security A. If security B has a beta of 2, the MRP on that would be 14%.
Yeah.
Or if one has 0.5, and it'd be 3.5%, that sort of thing. Yeah.
Okay.
And
So
here,
this example with like C above the line and D below the line, I think you're just going to get to that, but I'll let you talk. Sorry.
yeah, no, I was, but go ahead.
Well, I was just going to ask, like, do those returns like slowly change over time, or is it the beta that changes, or how do you know like which one?
Good question. It's the beta shouldn't. It's assumed that the beta does not change, at least in the model, in the setting of the theoretical model. But what does change is the price. All right, and again, the same exact argument that we just looked at would apply here, because here C, we've got a beta of that, and we should be getting a return of this. We're actually getting too much return, so the price is too low. So people are going to be wanting to buy that, which will drive up that price. Remember, this would be my $1 at the end of, maybe $1 at the end of time. Whatever the price is at the beginning, that difference is too big. And so as people demand C, they buy, that drives that down. And so basically that excess demand will drive C straight down back to the line. And likewise with D, it has too little return. And so people are selling that, and that decreases that price and increases the return and eventually drives D up to the line. And that's why that when we started off with, I think it was chapter 7, where we talked about what keeps a market efficient. We've got the rational individuals, participants. We've got that the irrationalities cancel each other out. And then we've got a third thing, that arbitrage is in the marketplace. And usually it's that last one. It's usually arbitrage. People see this and they go, "Oh," and it really relates back to like with Myers. People analyze the companies and go, "Wow, this is really a good deal." They're gonna outperform over the next year. I'm putting a strong buy on this, and so people will go, "Well, yeah, okay." So that may be one of these guys. It may be a C. And if you think about chapter 13, where we talk about various measures of performance, that's where we're picking up that alpha. So that's what we call a positive. The C would be a positive alpha. Yep. And D would be a negative alpha. So all of this. Oh, sorry. Go ahead, Ray.
Now, would you be kind of calculating that slope for the whole market and then adjusting individual securities from there?
Yep.
Okay.
Yeah. Yeah, and there's a lot of nuances in there, and actually the theory itself says that everybody is always priced correctly, and it gets off into the weeds. They also make the assumption, if there is a new security, that everybody alters their portfolio just a little bit, imperceptible amount each of us, but that's not necessary to understand the mechanism. We could assume that it's one person who's an arbitrager with a bunch of cash looking for alpha, right?
Yeah.
Yeah. So all of this stuff really ties together quite nicely, especially these latter chapters. The one exception I would say would be chapter 10, which is fixed income. But chapter 7, 11, 12, 13, those four chapters all really kind of lay out the basic framework for asset pricing.
Okay. I think that sums that up. Thank you.
Okay. Yeah, good question. Hey, Hannah, I didn't see you join in there. How are you?
Great. How are you?
Good, good, thanks. So, other questions, Rye or Jonathan, Hannah?
I'll let someone else jump in.
All right.
I don't have anything right
Excuse me, kind of just for clarification, in your first example there, I'm not sure if like I'm just missing the point here, but how did you get that middle rate of return? So like you have the like 9.03 and then like the 9.7 one, and then
Yeah.
you like somehow found one in the middle. I think I'm just missing how you made that middle of the road one.
So what I did was I just, to get what that number was, if it pays $1 here, I've got assets, got A, the price of A at 7.5%, I simply did this, right? And that gave me the 0.9, what was it, 9302? 1 divided by point 0.075. Yeah, 93023. And then B was the same thing, except I used the 667, and I got 0.93. 75, and that also paid off $1. And so this was at the beginning of this return was 7.5%, and this would have been that 6.67%. Right. And so buying pressure, everybody wants A. So there's excess, demand is positive there. Demand decreases on B. So the increased demand on A might drive that price up to, let's say, instead of 93023, 931 is the next move. And so for that, I get a return of, wait a minute. So it's 1 minus 0.931 over 0.931 is 7.41. So there's my, and then this, so for asset, that's asset A. As I'm selling, as the selling pressure builds up on asset B, it might decrease in price. So let's say it goes from 93.75 down to 93.5, for instance. Oops, 3.5 by 0.935. And so 1 minus 0.935 divide by 0.935, and I get 6.95%. And that process keeps going, right? So more demand on A means that the price of A continues to go up and the price of B continues to go down. At some point, we kind of meet in the middle. And that middle point would be if there was equal liquidity. I'm just thinking, here we've got 6 and 2/3, right? And then we have 7.5, so that's the way I was looking at it is like 1/3 gets us up to 7%, and then there's 1/2 above that. So common denominator would be 2/6 plus 3/6, so that's our 5/6, and so 2.56, or I guess you could read that as 5/12. So whatever that turns out to be, it's just a shade over 7%. Oops, sorry, I'm in the middle of that. Does that make sense? Is that what you were asking, Jonathan?
Yeah, I think I realized that like those two prices, I wasn't sure where you're getting like the 0.931.
Oh, I just made it up as the prices shift. This, say there's one more trade, excess demand trade, and then that's driving the price. Driving the price up, and so I just made these prices up as movements up for A. So this would be the A moving up, and then this would be B moving down. And then the next trade, same thing happens. We go from 0.931 to 0.932, and we go from 0.935 down to 0.934 or 3, and they meet kind of in the middle. And that'd be that 5/12 of a percent. So just a little under 0.5%, and so that takes us up over 7 point what 1.5, something like that, somewhere in that neighborhood.
Gotcha. And then just to clarify, the fractions at the bottom, is that like the liquidity ratios and determining like how like where in the middle exactly would meet, provided like
Down here?
liquidity, or yeah.
Oh, I'm just making that up, right? The way I got it, the way I looked at it was, I said, well, look, if I got 7 here and I'm down at 6 2/3, and I'm up here at 7.5, 7.5. There's my half, right? There's my third, and then I split that difference, and I'm right somewhere right there. That's all I was doing there. Yeah. This is the third away from 7 is that. The half away from 7 is this. I was just using that as a simple tool of adding up the difference. That's just the way my math works for me. And then, ultimately getting over here to half of that difference is 5/12. What's 5/12 anyway? Now, 0.416.
All right, perfect. Thank you.
Sure. What else? Anything else there in terms of, oops. Shouldn't have done that. Anything else in terms of that chapter, or do you have other questions in terms of problems or conceptual? This is a great conceptual one to get for sure. Hannah, I know you were on maybe not a great connection there. Did you have anything?
Just what everybody else has to say.
Okay, all right. I was going to say I just barely. Your connection is still not good, but you can always text me too if you have a. I can give you my my text number.
Ryan, you can go if you want.
Oh, I can't. You're on mute, right?
Oh, sorry, I just had one question from like way back chapter 7.
Sure.
I wasn't sure if I was reading this right in the textbook, but
Yeah.
I was going back to like weak form, semi-strong, and strong form markets. And
Right.
I just wasn't sure if those are. I wasn't sure if I was reading it right, that those like aren't necessarily mutually exclusive. Like a market can be semi-strong but also be weak, and I wasn't really sure about how to conceptually wrap my head around.
Sure. Yeah. Let me go to this this diagram as always one of the better ones to look at that kind of that circle, overlapping circles, concentric circles, I should say. So to use this, basically, if a stock is at least weak form, or rather, I should say, at most weak form efficient, what it means is that if you use the price and the volume data, and you look for patterns, technical analysis, basically. If you're using what most people call technical analysis, you're making some, you're doing, say, a 50-day moving average and a 200-day moving average. When one crosses the other, it's a buy signal. When the other crosses the one, it's a sell signal. That kind of stuff. If you can't make excess profits or abnormal, wait a minute. I better be careful. I don't want to talk about excess returns. So strike what I just said. Let me be more careful with my language. If you cannot make abnormal returns by analyzing the price and the volume data, then markets are said to be weak form efficient. So that's the lowest hurdle. Think of that as the lowest hurdle. There's also a nondescribed or not defined version below that. So if you can make abnormal returns just using price and volume data, then markets aren't even weak form efficient. All right? And the other two are above, so they're definitely not the other two either. All right? So then we say, well, if let's assume markets are weak form efficient for the moment. Now let's look at some other data. In other words, all publicly available data in addition to prices and volume. So we're talking 10Ks, 10Qs, anything in the business press, anything about the company that we find in analyst calls, all the analyst reports for that matter, because that's more or less public, whatever is publicly available. And we analyze those. And if we can't make abnormal profits by analyzing all that information, like what we did in class, right? Then markets would be semi-strong form efficient. And by definition, because this is why these circles are handy, if it's weak form efficient only, then it's just weak form efficient. If it's semi-strong form efficient, that includes weak form. So if it's semi-strong, it has to be weak form efficient as well. And then the strongest form is when we analyze not only all publicly available data, but all data available both publicly and privately held. So if I know something and nobody else knows it, and I still can't make a profit off of that, then markets are said to be strong form efficient, which means that they are also semi-strong and they are weak form efficient. So, that's the hierarchy. Weak at the bottom, strong, semi-strong includes weak, strong includes semi-strong and weak. Yeah.
Is it basically saying that, whether it's strong or weak, is that saying how much information you can have and still not beat the market with that information?
Yes. Yeah. I thought you might be headed another way. And yeah, right. Exactly. So that's it. And be careful because I've in years past, it's easily confused with we don't use any of the information. Actually, we use all of the information. It's always out there. It's just a question of using that information, can we make abnormal returns or not? And if we can't, and we're using all publicly available information, then markets are at least semi-strong form efficient, which means they're also weak form efficient. Yeah, another good question because these are the key concepts through this whole thing. So understanding that well and understanding the stuff that we were just talking about out of chapter 12 is really important. It'll, it won't make the difference. It may not make a huge difference on the exam in terms of grade. You may get one right or two or three out of that, but it makes a big difference in your understanding of the material when you're out in the real world too. So, good question. What else?
I guess I can chime in with another question.
All right, go ahead.
It's not necessarily like a concept or definition. It's more like kind of like, and I'm not sure if this is a cop-out question, like how it'll appear on the exam.
Mm-hmm.
I'm going over chapter 8. That was like the last thing I read through recently.
Okay.
And I'm just kind of like, because a lot of it's just like, just different behavioral kind of like abnormalities, if you will, like the snake bite problem and like myopic and all those other different things. And I'm just curious, is that going to be like more confined to the definitions and like matching section, or is that more of a like analyze a problem?
Yeah, well, they're going to be some of both. For sure, there's a lot of terminology in that chapter. And so, yes, you'll definitely see some of those terms, representativeness, heuristic, all the various fallacies that are showing up in that chapter. And so, yeah, you'll see that in matching, but you'll also see there might be a question about, somebody walks into a casino and they bring in $100. They hit, a lucky number, and they now have $500, and they spend the $400 as though it weren't their money. What's that called? So that could be a multiple choice one, right? And, there might be A, B, C, D, money fallacy. It might be, of course, this is house money, right? This is the idea that it's not really our money, and in fact, it is our money. And a couple of other distractor answers. So, yeah, you'll see both. Absolutely. Yep. Yeah, there are certainly some chapters that are lighter in analytic stuff. I would say chapter 10 is probably one of the more difficult ones in terms of analytical stuff. Make sure that you're up to speed on the how to do duration, and be careful if you use those closed form solutions for duration. Look really carefully. There are 3 of them. Oops, pardon me. Didn't realize I didn't have that on mute. All right. There are 3 of them. One of them is for, luckily a scam. One of them is for a par value bond only. You'll almost never use that. Now, there could be a problem that says, hey, it's a par value bond, and then you plug it in, easy peasy. The other 2, one is for semi-annual, and the other is for annual. Make sure you look over those formulas. So, for instance, on the semi-annual one, in fact, let me take us over there. And all right. Oh, too far. Yeah, here we are. Okay, so these guys right here, right? So, for the semi-annual one, be careful. M is the same M as in the annual one. In other words, M is years, right? Because you'll notice up here in the semi-annual formula, it has 2M over on the denominator there on the far right. That's to say, hey, we've got how many 6-month periods in 5 years? Well, there are 10. So make sure you plug in M as in years, and you'll know that exponent will turn out to be 10. in the case of a 5-year bond. Down here in the annual one, you just plug in the 5. So be really super careful of using those formulas. Now, of course, this third one down here, this one, oops, there we go, is the more generalized version of duration. You can use that on, actually, I take that back. That one is set up for semi-annual. And in fact,
Could you theoretically redo that one?
yeah, I do have to redo that one. I've got a mistake in there. Either I need to get rid of that divide by 2, or I need to make that exponent 2t. Let me fix that. That one is going to lead you astray.
I was going to ask about that in the semi-annual equation too.
Uh-huh.
So in the numerator of the right part of that equation, it has 2 times the coupon rate.
Yep.
Sorry, m times the coupon rate minus field maturity.
Yep.
And then it raises the figure down in the denominator to 2m.
Right.
So would that in the numerator be 2m times?
I think. Let me double check. Right. I think that one is actually correct.
Okay.
And I'll tell you what. Let me go. Come on. I need to get back to. There we go. I'm pretty sure that one is correct. That comes straight out of the book, and I flubbed the other one though. There we go. Okay, so I just want to get over here to right there, I think. Yeah. Yeah, that one is it is M. Yeah. But that third one from the top, that's the one with the summation sign in it. That's the one I have to fix. What I will do is I will just get rid of that divide by 2. And I'll change that. I'm going to change the nomenclature there a bit to make it more generic. I'm going to change the M to a capital T just for time periods, and try to make that so that it's not confusing. But yeah, I just realized that I had an error in that one. So yeah, pay some attention to 10. Those problems are probably some of the more difficult ones. And let's see, certainly 13 has got some challenges in it in terms of knowing all those various metrics. Sharp ratio, Trainer ratio, when do you use one over the other, Jensen's alpha, some of the other things we looked at in there. 11 and 12, know how to be able to calculate the standard deviation or variance of a portfolio as well as the expected return on that portfolio. When you're given either the standard deviation and return on the individual securities, or even when you're given the returns in each state. And kind of make sure that you're clear on those formulas and when to use each one. So for instance, going back to here in chapter 11, you've got this formula right up at the very top, sigma squared of P. This top one is for a 2-asset portfolio. The one below that is for a 3-asset portfolio. And you use those formulas when all you know is the standard deviation or variance of the individual securities within that portfolio. if you have something like those state returns, like we saw, let me go back to the chapter, and we'll go to chapter 11. Where we're looking at that star sense in JPOD, right? And we had different states of the economy. So we had, in this case, we just had two states, recession and boom. And we had the returns on star sense and JPOD in each of those states. Then we use this formula to get the portfolio return, to get the security return. And then we use the standard variance formula for variance to get the variance of each of the individual securities, and that is noted right down here in this table. So the trick hit there, look and see what the problem gives you, and that'll tell you whether you're going to do this or whether you're going to use that other formula on the formula sheet. And one last thing on, one last thing on that, at the end of the formula sheet, you can ignore this stuff from chapter 16. At the end of the formula sheet, I've got this in here for you. So in terms of calculating variance or covariance, you can use these. Let's see, anything else that you guys can think of?
I don't think I have any more particulars, but just about the exam, is it pretty much the same? You might have gone over this, but just the same structure as the first one, just matching and multiple choice?
It is, yep. It'll be 2080 or 2575, something like that. Yep. Similar number of questions, too.
Okay.
And the only difference is that this time you'll have an hour and 50 minutes to do it instead of an hour and 15. So, yeah, you guys have had some good questions. So, if that's all you have, we can wrap things up. And certainly, if anything else comes up, I'm going to be checking email till at least midnight. So if you do bump into anything that you're unsure about, I'll get back to you on email.